Hey everyone, welcome to Edureka's YouTube channel. My name is Anirudh and I'm here to explain functions in this brief session and show you how their usefulness has been best utilized in one of the most commonly used general purpose programming languages of today. You're right, I'm talking about Python. Now before we move on to begin this brief session, let me quickly show you a snapshot of all of the topics that we'll be discussing today. We'll begin by checking why we would actually require functions, and later we'll move on to knowing what the functions actually are and what they do. We'll be checking out the types of functions and all of the concepts involved with it as well. And definitely the most important thing here is that we'll be checking at code at every point of time to make sure we take the practical approach into learning the language. So I've received really good feedback when I use this approach, and I hope you guys can make good use of it. So without further ado, let's check out why we actually require functions. So guys, here I have for you a really simple use case. Consider this program, right? So let's say you actually write a program in which you input a Celsius number, let's say a temperature of course, and this must be converted into Fahrenheit multiple number of times. What would you do? We first obviously start with the logic, right? So Fahrenheit is equal to 9 by 5 into the particular Celsius number plus 32. So this is the logic to calculate for Fahrenheit. Well, here's the program to calculate for the Fahrenheit, right? So we collect the input from the user. We enter the Celsius value. Again, the value in Fahrenheit has been converted and it has been printed. Well, it is really good, right? So this has been done once. But what if you actually want to do it multiple number of times? Well, let's say you have 1 Celsius value, then definitely it is really easy, right? So let's say you have 3000, 5000, let's say you have 1 lakh values that needs conversion in real time as well. So when this happens, you wouldn't want to repeat the same lines of code, right? Well, this is the number one cause of inefficiency and ambiguity, guys. Well, I'm sure you already would have guessed it, right? So Python functions definitely solves this. Let us check out how it can be done. Well, just before that, let me give you another instance. We have something called as dry. Well, dry is don't repeat yourself. In the sense, when you're actually writing your own functions or when you're writing any methods, make sure that the reusability of it is really high. Functions not only reduce the code in your main program, but they also tend to make your code run faster and better. So what does this do? This actually increases the readability of your code and then makes it very easy for debugging and documentation as well. Consider this easy example, right? So every time you turn on or turn off your television, there are certain functions built in, right? So as soon as you flip the channels or say adjust the volume, there isn't anyone in the backend writing a code at every point of time to actually adjust the volume or flip the channels for you. There is a particular code which repeats itself and doesn't create any new instances when you actually adjust the volume or flip the channels, correct? So this is again very good efficiency. So as soon as you change the channel, there is a function which runs which says that the user has changed the channel. So let me do these certain set of codes. Again, similarly for the volume as well. So if you have increased the volume or decreased the volume, the function gets an input of what you're actually doing. And then this function actually works on your input and then decides an action. In this case, it's volume. Pretty simple, right? Well, now that we know why we need functions, right? So let us check out what functions actually are. So what are functions, guys? I'm pretty sure every one of us has an idea at this point of time. So head to the comment section below and let me know what you think of it. I'd love to interact with you guys there. So coming back, what are functions? Guys, functions are actually a way to break problems or processes down into smaller and independent blocks of code. Straightforward, right? So it's basically a block of organized reusable code that is used to perform some similar task. In our last case in television, it was either adjust the volume or change the channel. Well, coming back to Python, it can be called by its name when its tasks need execution. You can also pass the values to it and have return results to you. Do not worry, I'll be walking you through a range of functions so you'll have a better clarity at this point of time. Well, at this time, all I want you guys to do is to know about the def keyword. Guys, def stands for define, and this keyword is actually used before the name of the function. And its name is followed by the parenthesis before a colon. Well, this defines an entire function. Check out this particular example code I have for you. So we have def function underscore name, and this function does nothing and pass. Definitely, right? So we haven't passed anything there for the function to do anything. Well, def is the keyword here. Function underscore name can be anything. It can be my name Anirudh, it can be Edureka, it can be anything that you like, right? It's as simple as that. So let me quickly introduce you to another concept called as docstring. So guys, what is docstring? It's actually called as a documentation string. So it's basically the first string after the function header is called, right? So this particular thing is called as the docstring. Again, as I mentioned, it is short for documentation string. Check this particular example out, right? So we have print greet dot underscore underscore doc underscore underscore. What does this do? Well, this function greets to the person passed into the name parameter. So if there's a name parameter in the documentation, the function actually greets the person which is passed by the name. Simple. Now check out this important flow I have on the left side for you guys. Again, we're going to come back to this, but right now you need to know this. We actually first define a function followed by the function name. We have a certain set of code, right, in the function or away from the function or anything. Well, good, we actually wrote the code until now. Well, later when we actually need to use it, we actually call the function by its name. As you can see, define function name will actually define that particular function and what that function actually should do. To call the function, and by calling the function I mean to actually make use of the function, we just use the name of the function. So here instead of def function name in the second line of code, we have function name. So this is where we'll actually be using the code. So this sort of flow is actually important and I want you guys to note this at this point. So now that we're good with the basics, next up I want you guys to check out the different types of functions available in Python. So guys, there are two main types of functions in Python. First one is built-in functions and the second is user-defined functions. Well, as you might have already guessed it, built-in functions are already available with Python natively and user-defined functions are something which are defined by the users, right? So there are n number of built-in functions for almost all the users, guys. So for the sake of simplicity in this tutorial, I have considered the built-in functions which are actually part of the native Python package. Well, with Python, as you already know, there are n number of libraries. So each library has multiple functions on its own. So as soon as you go into the depth of one single library, you'll get access to all of their functions as well. And in user-defined functions, again, as the name suggests, you can define whatever you want. So basically, let me give you a quick simple example, right? So consider the example of a calculator. So let's say 3 plus 5 is equal to 8, right? So let's say a plus b equal to c. You've written a function. You're going to pass the values a plus b and then you have a function which automatically gives you the value of c. And you don't have to write a plus b equal to c all the time. So we are basically trying to reduce the amount of effort put in by the user and increase the readability as well. So there is absolutely nothing to lose when you make use of functions and its advantages from the start to the end. And it's all advantages from start to the end. So let me quickly walk you through some of the major built-in functions which are available in Python. So guys, the first function I have for you is the absolute function. I am sure many of you can guess what the absolute function already is, but let me walk you through this function, right? So first I have the definition for you. So basically the absolute function returns the absolute value of a specified number. Well, that's confusing. What do we mean by absolute value? Consider this particular syntax an example. Well, the syntax is abs of n. Here abs is the keyword and n is the parameter passed. So n can be anything, right? So it can be 0, it can be 100, it can be anything. It has to be an integer here, guys. That is really important to note. So here all we're trying to do is we're trying to return the absolute value of a number. So consider the example, right? So we have a complex number here. X is equal to absolute of 3 plus 5j. Well, what does this do? So this basically calculates a number for us, which is actually a complex number in this particular case, and then provides the absolute value for it. So let's say instead of a complex number, we had absolute of minus 7. What do you think was going to be the answer, right? So it's going to be 7, obviously. So in this case, it was minus 5.83. And since it's absolute, minus has been removed and it's here. So what is the answer to x is equal to absolute of minus 10.5? Can you guys take a guess? Well, definitely it is 10.5, right? So there is no negative in terms of absolute. Simple and straightforward. Here, the parameter which is n, it is actually a number. So make sure you don't put any string input such that you can avoid all the errors. So the first function is done. So let's quickly move on to the second one. So guys, the second function I have for you is the all function. Well, the definition actually says this. The all function returns true if all of the items in an iterable are true. Otherwise, it returns false. But what are the iterable items that we're talking about, right? So it can be lists, it can be tuples, and it can be dictionaries as well, right? But you need to note one thing about the all function. So if the iterable object is actually empty, then the all function will still return true. So let's quickly take a look at the syntax and the example and the output as well. So syntax all of iterable, you already know that the all here is actually a keyword. Check out the example. We have a list here, right? So my list is equal to true, true, true. And x is equal to all of my list. Well, it's basically telling us that all of the elements present inside our list is actually true and it matches. So as soon as you check out the output, it says true. Why? Because everything is true. This is the same case for lists, tuples, and dictionaries as I mentioned, so make sure you note that as well. Pretty simple, right? So we already covered two functions in such a short amount of time. Let us quickly jump into the third one. So this third function is a very interesting function, guys. So it is ASCII. I am pretty sure many of you actually know what ASCII is, right? So ASCII actually stands for American Standard Code for Information Interchange. And all it does is it is a character encoding standard, guys. So it is basically used by computers to actually understand. So we understand A to Z and 1 to 1000 or 1 to million, right? So how can computers make sense of this information in their low level language is exactly through ASCII. So what does the ASCII function do in Python? Well, the ASCII function actually returns a readable version of any of the objects. Here objects are strings, tuples, and lists or anything, right? And the ASCII function will actually replace any non-ASCII characters with escape characters. So if it's an ASCII character, well and good. If there is no ASCII character, it will actually escape that particular character, guys. So here's the syntax. Check it out. We have ASCII of object, again ASCII being the keyword and object being the parameter. So what is the object parameter here, right? So it's a string, it can be a list, it can be a tuple, it can be a dictionary, and anything you want in your particular instance. Check out this simple particular example here. So we have an x equal to ASCII and my name is Tale. The A here is spelled very differently and it does not have an ASCII value mapped to it, right? So if it was just stale, then you would actually get the ASCII output. Well, since here it is not a valid ASCII character, Python actually puts an escape sequence there and it actually escapes that particular thing and prints out the rest of the thing. Simple, right? Well, I'm going to assure that all of the functions are actually as easy as this, and then it would make your life easier to know what each of these functions. And at the end of the day, it will make your life really easy knowing what all of these functions do. So on that note, let me quickly move to the next function. So the next function I have for you guys is bool. Well, bool actually stands for boolean. Can you quickly take a guess again? Cool, I am sure you would have guessed it by now. The bool function actually returns the boolean value of a specified object. Well, it will actually return true unless it meets empty parentheses or empty brackets, or if the object is false, if the object is 0, and if the object is none as well. So all these cases are when it can be false, but any other time it will actually return true. So let me quickly walk you through the syntax. Bool of object, bool being the keyword, object being the parameter. So what is the object in this particular case? It can actually be string, it can actually be list, it can actually be number or anything, right? So check out this particular example. X is equal to bool of 1. So as soon as that happens, since it doesn't match with any of our false criteria, we got it as true. Simple, right? And now that we are actually done with the bool function, let us quickly check out our next function. Next function is enumerate, and this is definitely interesting, guys. So the short form of enumerate actually stands for enum, but in Python we actually use enumerate. So in case you're coming into learning Python from an other different language, say C, C++ or Java or something, you would realize that enumerate here is the same as enum there. Again, let me quickly show you the definition of it. So the enumerate function actually takes a collection. Again, a tuple is a collection, right? And it takes this as input and returns it as an enumerate object. The enumerate function adds a counter as the key of the enumerate object. Let me give you some better clarity on this. Check out the syntax, right? So enumerate, and it has two parameters instead of one. So one is iterable and the other one is start. What is iterable? So we already checked out what iterable objects are. And then we have something called a start. Well, start is actually a number. We're trying to define the start number of the enumerate object. Well, if you don't put anything, it will be 0. Well, check out this particular example right in front of you, right? So we have x is equal to apple, banana, cherry, and y is equal to enumerate of x. So again, the default value is 0. So Python already counts from 0 instead of 1, right? So obviously apple becomes 0, banana becomes 1, and cherry becomes 2. And you can actually play with all of these key mapping values and then operate on them later as well. But at this point of time, all you need to know is this. Python starts from 0 and the first object there, first iterable object there actually starts from 0. So apple maps to 0 and so on from there, guys. Simple, right? And now that we are actually done with the enumerate function, let us quickly check out the format function. So what does the format function actually do? So guys, the format function actually formats a specified value into another specified value. Well, that was a bit complex, right? So let me quickly simplify that for you guys. So check out the syntax. We have format and we have two parameters, value and format. Well, a value can be a value of any format, guys. And then we have something called as format. Guys, I'm talking about the parameter here and not the keyword. So basically we have multiple parameters, guys. So we have lesser than. So lesser than basically left aligns the result, and then we have right align, and this actually aligns the space. Then we have is equal to. So this basically places the sign to the leftmost position. And we have minus. So this is actually used for a negative value, as you already know it. Then we have B. B actually converts it to binary. C converts it to Unicode. D to decimal. F to a fixed point number. G to general point, and so on, guys. And if you want more, it is basically O for octal, lowercase x for hex, uppercase x for uppercase hex format, N for number format, percent for percentage format. But in this particular case, check out this example. We have x is equal to format of 0.5 and percentage, right? So 0.5 in percentage is what? So it is basically 50%, right? So it is basically half. So 50% is your answer. Another function, done. So what is the next function I have for you guys? Guys, the next function is actually get attributes. So basically it is shortly called as get attr. Again, a keyword. So what does this function do? Guys, the get attr function actually returns the value of the specified attribute from a specified object. Again, looking at the syntax, we have get attr, we have the object, attribute, and the default parameter. The object is compulsorily required because we need to know what we are working on, right? So this is the compulsion, and then next we have the name of the attribute, right? So basically it is the name of the attribute from which you want to get the value from. And next we have default. Guys, default is optional here. So what does it do? Basically it is the value to return if the attribute does not exist. So in case there isn't any particular attribute to return to, it returns to this default value. Check out this really simple example I have for you guys. So we have a class called person, name equal to John, age equal to 36, country equal to Norway. X is equal to get attribute of person and age. So at this point of time, what we're trying to do is move into the class person, find me the age of this particular instance. So in this particular case, John's age is 36, and that is exactly what we see in the output. Pretty easy, right? And now that we're done with the get attribute function, let's see what's next. So this is an interesting function, guys. So I have the identity function for you guys. So guys, this is an interesting one, the identity function. Also for short, it's called as the ID function. So what is the definition of this function? Guys, the ID function actually returns a unique identifier for any specified object. So all the object in Python has its own unique identification, right? So the ID is actually the object's memory address, and it will be different for each time you run the program. Check out the syntax and the example, guys. So ID of object, as you can already tell, ID is the keyword, object is the parameter. Here the object can be anything, guys. It can be a literal object, it can be a string, it can be a number, it can be a list, it can be a class or anything as such. Check out the example. X is equal to apple, banana, cherry. Y is equal to ID of X. Well, this particular object created has the identification as this. So when you actually perform operations on this particular object on X, and then Python basically tracks it in the background using this particular identification, guys. So every object in Python is actually mapped to a particular unique identifier. It may not be the same every time, but what is important to note that it actually has a unique identifier. So if I probably ran this program twice and then showed you the same output, it would actually not be the same because another identification number would have been provided. So identification function is as simple as that, guys. So let us quickly move on to the next function. So the next function I have for you guys is the length function, and it is shortly called as len. So guys, the length function basically returns the number of items in an object. So consider this, right? So when an object is a string, the length function actually returns the number of characters in that particular string. Check out the syntax. So we have len of object, right? Again, object is definitely a mandate here because we need to know what we're trying to find the length of, right? So either it must be a sentence, it must be a string, or it must be a generic object, or it can be a sequence, or even a collection as well. So check out the easy example I have keyed for you, right? So my list equal to hello. So we have one word here, right? So it consists of 5 letters. So as soon as you print x equal to len of my list, it realizes that this is a string and it prints the number of characters. In hello, there are 5 characters, and as you can see, the output is 5. Well, length function done. Guys, the next function I have for you guys is the map function. Can you quickly take a guess on what the map function actually does? So guys, the map function basically executes a specified function for each item in an iterable sequence. So this basically tells us that the item is sent to the function as a parameter, right? So we need to know what we are actually doing here. So check out the syntax. Map is the keyword, and we have 2 parameters, which is function and iterable, guys. So function is definitely required because we need the function to execute for each particular item, right? And then we have iterable. Well, in this particular function, again, iterable is also a compulsory requirement because we need to know, right? We need a sequence or we need a collection or an iterator object or something to work on. So you can basically send as many iterables as you can and just make sure that the function has only one parameter for each iterable. Quickly check out the example and the code, and I'm pretty sure you guys will figure it out on your own. So basically we have defined my function of n, again defining the function name of the function is my function, my func, and then the parameter is n. What we are actually going to do is we are actually going to return the length of our input parameter. Check out the next line, x equal to map of my func, and then we are passing it three values, apple, banana, and cherry, right? So what do you think is the length of this? So each individual object can be iterable, right? So apple has 5 characters, hence 5. Banana and cherry has 6 each, so 6 characters each. Again, pretty simple and widely used, guys. So this function actually helps you a lot when you're actually trying to map something to a key or when you're practically trying to make use of this. So now that that's done, let me quickly walk you through the next function. So guys, the next function I have for you is the min function, min or minimum, right? So this function basically returns the value with the lowest value, or it returns as an item with the lowest value in a particular iterable. So if the values are strings, then alphabetic comparison is actually done. Let us quickly check out the particular syntax here. So we have min of n1, n2, n3, right? So it can be any number of numbers. And then we can have another syntax actually, right? So what do we do if it's an iterable? So instead of n1, n2, and n3 or so on, we're gonna have min of iterable, guys. As simple as that. But check out the example here for simplicity's sake. We have x is equal to min of 5 and 10. So it's as simply as saying what is the minimum of 5 and 10. So which value is minimum here? 5, right? So if I had to give you another example, what is the minimum of 1000 and 10,000? So whatever is the minimum number is output, right? So in that case, it was actually 1000. So it is as simple as that, right? So I don't think I need to explain more about this. And you guys got a pretty good idea about it already. So moving on, next I have for you guys is the POW function. POW stands for power. So it's basically exponentiation here, guys. So the function actually returns the value of x to the power of y. Well, in this particular case, x raised to the power of y, guys. So there are two parameters present, right? So what is the base and what is the power? So if there is a third parameter, then it returns the x to the power of y and the modulus of z. Quickly check out the syntax and the example, guys. So we have 3 parameters in this case, right? So it is pretty simple to pick up 2 parameters. So let's say what is 2 power 3? The answer is 8, correct? So what is 4 power 3 again? It is 64. If we actually require the modulus of this answer, then that would become our z parameter in this particular case. Since we haven't done it, 4 power 3 remains to be 64, and that is the exact output that we get. Simple, right? It is as simple and as easy as that, guys. So next up I have for you is the print function. This is probably the first thing that you would learn as soon as you start Python, and this is definitely not the last thing. And this is definitely not as easy as it sounds. So it basically prints the specified message to the screen or any other standard output device. Well, most of the time it is the screen, but you can actually do it to other devices as well. So print. So print, we have objects, then we have separators, and we have files, and we have flush, and we have so much around here, right? So let me quickly walk you through all of these in a simple way. So objects basically refers to any object, right? You can have any number of objects you want. All of these will be converted to a string before it is printed. And then we have separator, guys. Guys, separator is actually an optional parameter, and you specify how to separate the objects if there is more than one object present. The default separator is actually double quotes. And then we have end. Well, again, another optional parameter. So we use this to basically specify what to print at the end. The default is actually /n because again, we're going to move to the next line as soon as something is printed. And then we have file. All of these are optional, guys. So basically file and flush, everything is optional here as well. So file is basically an object with a write method. That's it. But what if there isn't anything? Well, the default parameter of the file object is actually sys.std_out. So it is the system standard out, guys. And lastly, we have flush. Well, again, flush is another optional parameter as I told you. And this is basically a boolean specifying if the output is true or false. Well, here is a computer science term for you guys. If the output is true, we call it to be flushed, or if the output is false, we call it to be buffered. What is the default output? It is buffered. So what is buffered? Buffered is false. So the default output is false, guys. Again, probably the most widely used example ever I have for you guys is printing hello world. So print, Our separator is the double quotes and we're printing hello world. Again, I hope no more explanation is needed for this particular function, guys. So moving on, we have the set attribute function, guys. So this function basically sets the value of the specified attribute of a specified object. Again, object here is required because we need to know what we're working on. The attribute is required because we need to know what attribute we have to set and the value, right? So we need to know what value to what attribute we set. So if you already remember, we actually did the get attr, right? So we actually outputted a function and now we're going to basically set it. So check out the simple code I have for you guys. We have class person and then name equal to John, age equal to 36, country equal to Norway. Same as the previous example, right? So here we're using another syntax set attr of person, age and 40. All we're trying to do is instead of John having his age to be 36, change the age of John to 40. So go into the class person, look for age. So whatever is there, change it to 40. As simple as that. Again, this is a fairly straightforward function, guys. And next up I have for you is the sorted function. What does this do? Well, the sorted function actually returns a sorted list of the specified iterable objects. You can actually specify the ascending or the descending order as per your requirement. The strings are actually sorted alphabetically and the numbers are sorted numerically. As simple as that. But you need to know that you cannot actually sort a list that contains both string values and numeric values. So you either can do it for numeric values alone or string values alone. Got it, right? So check out the syntax. So we have something called a sorted and we have three parameters, right? So iterable, key and the reverse. Iterable is definitely required because we need to know what sequence we need to sort, either if it's a list, dictionary or a tuple. Key is optional, guys. Key and reverse are actually optional here. The key is basically a function which is used to decide the order. Well, what if you don't give any order? Default is actually none. And then we have reverse. So what is a reverse, guys? Again, it is an optional function as I told you, and it definitely is a Boolean function. So false will actually sort it to be ascending and true will actually sort it to be descending. Default is false, so default is actually sorting via ascending method. So check out this particular case I have for you, right? So we have a set of values for A. We have B, G, A, D, F, C, H, E, whatever, right? So X, as soon as we print sorted of A, the default value is false. So in this particular case, what happens is that, so it actually orders it for us in the ascending order. So the values actually went from being gibberish to be neatly sorted as shown here. Again, another easy function, done. So this brings me to the last built-in function for this session. So I have the type function for you guys. So the type function basically returns the type of a specified object. So again, check out the syntax. We have type, which is the keyword. We have object, basis and dictionary, right? So the first one is required. We need the object here because we need to know what we're trying to find out. The basis and the dictionary are actually optional. So basis actually specifies the base class and the dictionary actually specifies the namespace with the definition of that particular class. Well, it is not that you need to worry about this right now, but then definitely this particular parameter, which is dict, is actually useful later. But for now, since I'm introducing functions to you, let's stick to the basics. So check out this particular example. I have A equal to apple, banana and cherry, B equal to hello world and C equal to 33. So as soon as you try to find out the type of A, B and C, you can realize, right? So the first one, as soon as you look at it, it's a tuple. Second one, as soon as you look at it, it's hello world. And third one is definitely an integer, right? So A, B, C respectively. So again, as easy as that, guys. So those were a lot of functions, and I actually recommend that you guys pause the video at every point of time and make a note of all of the important stuff that I've said here, guys. So this will actually take you a long way in learning Python. Well, now that we're actually done with the built-in functions, again, let me quickly give you a recap and then start with user-defined functions, guys. So what are user-defined functions? Again, as I said, we'll be taking the code-first approach here. So here I have for you guys two simple syntaxes. So the first one is how we can actually create a function, and the second one is on how we can actually call the function. So we have actually looked at this when I previously told you, but let me quickly tell it again. So again, define my function. Define as the keyword. My function is the name of the function. So what do I want this function to do? I want it to print hello from a function. So this is actually the body of the function, and as soon as the function has been called, it's going to print hello from a function. Well, instead of print, I could actually make it to calculate something for me or print my name or print Edureka's name or anything as such as well, right? So the body of the function is completely left to your freedom, but make sure you check the number of parameters you require and all that you need, right? So now quickly look at how we can actually call a function. So we have defined my function and then hello from a function as well. To call this particular function, all you need to do is call the last line, guys. So basically we need to type out my underscore function and you're good. So how more simpler can you expect Python to be, right? As simple and straightforward as that. So then again, parameters, guys. So parameters are the information passed to functions that you already know. So let me quickly step up the complexity of our examples to one little notch higher, right? So again, check out. So we have defined my function and fname. Here, fname is actually the parameter of us. So we're printing fname plus refsness. So what we're trying to do, we're trying to pass. So this is our function body. So next, what we're actually trying to do is we're actually trying to print it. So we have my underscore function. We have provided three names there. We have Emil, we have Tobias, and we have Linus, right? So as soon as you go ahead and check out the output on the right side, so that is actually concatenated to refsness, right? Again, simple. So you can have any number of parameters and then work on all of these parameters and get whatever return output you want, guys. And get whatever meaningful return output that you want. So what is the default parameter value that we stumble upon all the time? Again, check out the example here. So we have defined my function country equal to Norway. So I'm specifying in my parameters that the country is equal to Norway. So no matter what you do, right? So in case you haven't provided any value, the default value it should actually consider is Norway. So we're printing I am from and then concatenating a value of the country. We've called the function 4 times, in which the first time we have set Sweden. So it's printing I am from Sweden. The second time it's India. So I am from India. Third time we have just called the function without passing any parameter to it, right? So this is the exact case where it moves to the default value. Since nothing is provided, it is actually printing I am from Norway. And then fourth one, my function of Brazil. Again, it is as simple as that. You've already provided the parameter, so print it as it is. So default parameter value, you got all of this, right? And then the important concept you need to know is the return value, guys. Check out the example. We have my function and x is our parameter. We're returning 5 into x. So basically, as soon as we pass a number, 5 is going to be multiplied to that number and we're going to get the output. My function of 3, 5 3s are 15, 15. So next we have 5, 5 5s are 25, 25 is correct. 9 5s are 45. Again, we have 45 as the output. So we're good with that, right? So let me quickly recap on how the function actually works. So we have one set of code and we actually keep using it in recursion. So recursion is basically a function calling itself. So check out this particular example I have for you guys. We have defined a function. We call it try underscore recursion. We have a parameter k. So if k is equal to 0, then add the result to whatever is lesser than the next iteration of this function. I know it sounds complex, but how you can actually analyze a recursive function is to take a pen, a paper, so to write down the values of k at every point of time and then to actually trace what is available in the memory, guys. So if that is the case and if the result in which k is greater than 0, we print the result. Else we print it to be 0 and we return the result. And lastly, we actually print the recursion example results and we call the function by passing it a value of k, right? So k is 6 in our case. So if k is equal to 0, absolutely 6 plus try underscore recursion of 5. Again, come into the function. Is 5 greater than 0? Correct. Again, go back. Check if 4 is greater than 0. Yes. Keep doing it until the result is 0, right? So it's pretty much obvious at this point of time, guys. So every time you actually run this, one value gets added to your program, right? So again, check out the output and you will understand this better. So we have 1 and then 2 values were added, we got 3. 3 values were added, we got 6. 4 values were added, we got 10. 5 values 15, 6 values 21. So all we're trying to do is add one extra value and print it using recursion. And that's about it, guys. So I hope this has been a good introduction to the Python user-defined functions as well. So next, quickly let us check out the Lambda function in Python, guys. So what is the Lambda function? Guys, it is extremely simple. A Lambda function is basically one small anonymous function. So it can take any number of arguments, but it can have only one expression at the end of the day. Check out the syntax here. So we have Lambda, arguments and expressions. Well, still nothing is working, right? Check out the example. We have x equal to lambda of a, where the expression is a plus 10. So as soon as we want to print something, all we need to do is we need to print x of 5. As soon as we hit x of 5, a gets the value to be 5. So since a gets the value to be 5, 5 plus 10 becomes 15. And we're printing x of 5, which is now 15. Pretty simple, right? So you basically can create tiny functions all on your own using the Lambda keyword here. So do know that the syntax is really important because we have the arguments on the left side and the expressions on the right side. So guys, here is another example I have for you. So we have a Lambda function that multiplies one argument with another argument. In our case, it is a and b. And we want to print the result. So check it out. X equal to lambda of a comma b, because a and b are parameters here. So what is the expression you want to perform between a and b? It is multiplication. So a cross b. and we're printing x of 5, 6. So a is 5, b is 6. What does 5 6 are? It's 30, right? Again, the output is 30. Pretty simple. Check out this other example. So basically, we're trying to find the sum of three parameters a, b, and c and print the result. So x equal to lambda of a, b, and c, three parameters a, b, and c, hence 3. And then we have a plus b plus c. So what is the sum of 5, 6, and 2? It is 13, and that is exactly what you've got in the output. So these are tiny set of functions that you can make use of any time without any dependencies, guys. So that is the important part I want you guys to notice at this point. But when you can have all the regular functions, why would you want to make use of the lambda function, right? I'm pretty sure this was the first thought that came into your head as soon as I explained the concept. Well, the power of lambda is actually better shown when you use them as an anonymous function inside another function. Check this particular thing out. We have defined a function which is called as myfunc. I have one parameter n. And then we're actually performing another function inside our function. And this is basically telling us to return the lambda of a cross n. So whatever n value has been provided, we're going to use the lambda function as in a tiny function there to provide us the multiplication of a value with a particular n value, which is the parameter. Simple. So check out this example, guys. So we basically use that function definition to make a function that always doubles the number that you send in. So we have defined my function of n, lambda of again a into n, right? So it's pretty much the same example. And then we have a variable called mydoubler, which actually is sending the parameter 2 to our n value. So what do you think is going to happen as soon as I print the value of mydoubler of 11? Pretty much simple. 11 gets multiplied by 2 because 11 is passed as a function into the myfunc through mydoubler. So here a and n becomes 2 and 11. So what is the product of 2 and 11? It's 22. Pretty much simple, right? So here's another last example. So basically we can use the same function definition to make a function that actually triples the number that you send in. So what I want you guys to notice is that check out the function definition. It remains the same. So define my function of n, return lambda of a into n, perfectly same. My doubler, my function on how many times you want to double it. So double is 2, so 2. My tripler equal to my func of 3. So I want to triple it, so multiply 3 times. As soon as I print my doubler of 11, 11 into 2, 22 is the first output that I get. Print my tripler, 11 into 3, 33. That is the second output that I get. So what I am trying to convey to you guys is that you wouldn't have to rewrite all of these functions at every point of time, right? So the definition of the function remained same. How we call it and how we get our output is actually depending on us. And that is what makes functions efficient and one of the biggest concepts that you need to learn in Python, guys. So with that, let me quickly conclude the session for you guys. So basically we found out why we require functions and later we moved to knowing what the functions are. And we checked out how we can work with functions in Python. And later we checked out all of the major built-in functions that are available in Python. And then I introduced the concept of user-defined functions as well. And lastly, we checked out all of the Lambda functions, and I hope you guys understood every single concept of this tutorial, guys. So in case you still have any queries about Python and in case you want to learn Python, so guys, it is at this point of time I'd like to tell you that I've curated an in-depth video on Python meant for beginners, guys. So I'm getting some really good feedback on that, so I want you guys to check it out and let me know what you feel about it. So we have in-depth videos for majority of the advanced Python concepts as well. And then make sure to check out the recent Python projects video as well. So that is it for this small session, guys. I hope you took away some real good points from here and that this helped you kickstart your Python functions learning. So thank you guys. You know what to do. If you have any queries, leave a comment and subscribe to our channel for more information on the latest technologies and the courses offered.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!